Welcome to the MTD podcast. I'm Giovanni Albanese, hosting today's show, a passionate engineer and a very proud member of the MTD team. Today, I'm privileged and really excited to be joined by the two founders of Fisher Smith Limited, a leading machine vision company. And I'm looking forward to find out how this technology can help with many automation solutions for all industries. Ian Smith and Bob Fisher founded Fisher Smith in 2004, combining their over 50 years experience of machine vision and industrial control systems. Ian and Bob have a love of solving difficult problems using leading edge machine vision technology alongside tried and tested techniques in conjunction with a variety of different automation systems. When machine builders and in-house engineers have a problem, they call Fisher Smith. So firstly, without further ado, let's introduce Ian. Ian has been at Fisher Smith for over 16 years and is widely recognised as a machine vision expert and software engineer. He was educated at the University of Bristol, where he read engineering mathematics. Ian developed Fisher Smith's leading machine vision system, RoboViz, and software, GenViz. Ian has taken a keen eye for digital, a keen eye for detail, and enjoys working with suppliers and customers alike to understand the requirements and deliver solutions. So welcome to the MTD podcast, Ian.
Thanks for having us, Giovanni.
No, it's brilliant to have you on board, and I'm looking forward to delving into your business and your solutions. So now let's introduce Bob. Bob has been at Fisher Smith for over 18 years and is also a machine vision specialist and software engineer. Before becoming MD, Bob served a MOD apprenticeship and worked for various companies, honing his electrics and software skills before developing Fisher Smith's leading machine vision system, RoboViz, and software, GenViz, with Ian. Bob loves to solve difficult industrial problems and delivers solutions that will stand the test of time. Bob's life outside of work includes activities as riding motorbike, cycling. He's travelled from Land's End to John O'Groats on a tandem and hill walking. He is a qualified canoe instructor, regularly running expeditions to all parts of the UK, and also plays in a folk band as often as he can. Well, that's one hell of an introduction, Bob. Welcome to the MTD podcast.
Cheers, Gio. I like keeping myself busy.
You sound very busy, Bob, and I believe, Ian, you've got a bit of a passion for football too.
Yeah. My playing days are sadly somewhat behind me now, but yeah, I do enjoy football.
Did you used to play professionally, or? Oh
no, nowhere near that level. Just kicking balls and other people in the local leagues. That was me.
So, guys, welcome to the MTD podcast. For our listeners in the UK and around the world, can you firstly tell them before we start what machine vision is and what sort of problems it solves? And if we can start with you, please, Bob.
So, machine vision is using camera technology to acquire images of objects and making measurements within those images to make either an inspection or an identification process, either recognise a part or check a part is correct or wrong, and then obviously gives you the option of failing that part or picking it up with a robot or something. It's all about non-contact inspection at high speed, so it can operate at sort of 10 parts a second maybe, or and far higher than that, but sort of the sort of thing you couldn't do easy with a probing system or with manual inspection.
Is this the future for manufacturing, Bob?
Definitely it is, yes. It's key, I think, to get high quality. Nobody wants to be shipping rejects out to customers. It's just bad business, and nobody wants to be adding value to a part that's already faulty by further processes. So the sooner you can inspect a part in a process, the better, really.
Right, so we're going to deep dive technically into the products in a bit more detail during this podcast. Now, how did you two meet, and why did you decide to start Fisher Smiths, Ian?
Well, I was when I was at university. Bob was working at a different company, and he found out what I was doing and invited me to come along and do some summer work for that company. And then I ended up starting my business career working for Bob at that company. And then after a little while, we decided to form Fisher Smith just to focus on the vision aspects more directly, and sort of never really looked back. So Bob's got so my career is very much vision, right from the word go. Whereas Bob started, he could probably tell you better than I can, more in the machine tool and the CNC areas, doing control systems. And then as the machine technology was coming through, then the vision technology was coming through, then Bob picked that up at a very early stage and started using it.
Yeah, that's interesting. That is because our listeners are predominantly from the CNC sector, metal cutting industry, and automation. Really, we've been really slow to embrace it in the UK. I think that COVID has certainly changed that, and we've started to see people investing in automation finally and seeing the value. Bob, vision was you've probably got into vision before its time, really.
Yeah, I've used many technologies before they even had a name.
Tell us about your background a little bit then, Bob.
So I started with working at a Royal Aircraft establishment, and I got into wind tunnel instrumentation and wind tunnel control systems, model positioning in wind tunnels. And when I left there, I went to finish up working at a machine tool company that was making high-speed routers for the aerospace industry for honeycomb materials, laser cutters, very much in the early days of laser cutting, and ultrasonic knife cutting. And I developed several control systems that weren't available from standard CNCs at that time. I had to write my own control systems software to control axes that couldn't be controlled by the CNCs at the time to do various tasks. And that's how I stumbled across vision as a means of controlling the positioning of cutters in material for trimming and identification. So the first we did was looking at digitising cowhides for Jaguar car seats.
And is this when you identified the potential for vision across many more sectors?
Yeah, I mean, it was clear to me, even at that stage, it's back in the 80s now, that this was clearly the way to go, and a good career choice for me to follow, really.
All right. So, for our listeners again, if you want to find out a bit more about Fisher Smith as a company, are you active on social media? Where can people find you?
Our website's probably the best place to start, which is fishersmith.co.uk. But we're also LinkedIn and Twitter. You can find us, and I think you'll probably have links accompanying this as well, or on your website.
Brilliant. Now, in a world of technology, and when technology's never been as important as it is today, digitalization, Industry 4.0, automation, it's been around a long time. Even Industry 4.0 has been around for such a long time, but people didn't really know what it was. How do your products, or where do you see your products helping companies succeed?
The obvious and main application has always been quality inspection, which has tended to be an end-of-line process. So you make the widget, complete manufacturing of it, and then pass it under a camera to stop any rejects going out to the customer. But that's only part of the story, really, because you've got the fact that the data, the quality data you're generating in that end-of-line point should really be fed back into the process to then allow you to optimize the process to stop the failures coming out in the first place. And I think that will become more and more prevalent as more of these devices are becoming easier to connect up with the sort of Industry 4.0 that we're seeing. But we're also seeing, as the technology in our area matures and becomes more affordable, it's now easier to deploy it earlier on in the processes. So rather than just inspecting the final assembly of the final product for all attributes at the end, we're seeing a no fault forward approach being followed more and more, where we have maybe a simpler inspection for maybe a single attribute earlier on in the process, because if that's wrong, there's no point adding more value to that component as it goes through the remaining processes of that manufacturing system. So we're starting to see those cameras getting smaller, more self-contained, sometimes cheaper, but spread out through the manufacturing process much more. So we're capturing bits of data at the key points.
Yeah, so it's some really good points there, Ian. I mean, if you can't check it, you can't make it. And I think that automated inspection is certainly something that's extremely important, for high volume work. But it's not just the inspection or automated inspection of parts that you can do, is it? You can actually, your vision system, if, say, for example, you've got parts on a conveyor, and they're just chucked on there in all different orientations, or you've got parts in a bin, your vision system can help the robot pick the parts out without them having to be in a kind of gantry style kind of format.
Absolutely, and this is somewhere where we're seeing more and more of this coming along, again, as our technologies in our industry have improved. Things like random bin picking, where you've maybe got a stillage of parts that have been maybe cast or partly manufactured earlier on in the process, sitting there, and they now need to be fed into some other process, a finishing machine or a printing system, milling or turning operations. We now have 3D systems that are capable of scanning that bin of parts, detecting which components are available to be picked on the top of it, looking for which ones would cause the robot collisions to come in, and ignoring those ones. And that's now becoming a viable technology. But that really has only matured in the last, 5 years, really. That's now not just a sort of academic dream to be able to do that. Whereas in the past, we've needed a bit more mechanical intervention, and sometimes that's still the appropriate course for these things. And Bob's, got a lot more history. In some of his main projects he's been working on in the past were around our RoboViz products, which was designed to help robots pick parts from conveyors. So maybe, Bob, do you want to say a bit more about RoboViz and those solutions that we solved?
Yeah, so we started with looking at bowl-fed systems, robot picking place with a fixture for every part type. So you have a common bowl, maybe you need a different set of fixtures to get the parts out of the bowl and into a form where the robot could pick them up. So the first task was to get rid of all those fixtures, so the machines could change over different parts much quicker. So we developed robots with that in mind. So it can recognise a variety of different parts. It can recognise which way up a part is. So if you're feeding a part into a machine, it needs to be a certain way around when it's presented into the CNC's jaws. Then we developed software to identify which way around it should go, even from a rough casting. And so then you still need a bowl to get the parts out in single file, maybe, because if there are parts that would tangle together, they wouldn't lend themselves to bin picking. So maybe they can be bowl fed out into a single file, or a tray of bringing down a pan of work at a time, maybe. So we developed that, and we developed a system that could pick up the where parts are on the belt and work out which is the most efficient fix cycle to get the ones that don't cause collisions, and the most efficient use of the available conveyor time and part presentation.
I mean, this is a bit of a game changer, isn't it, Bob, in regards to being able to do that, in regards to the time that you will save, the simplifying of the process. I mean, the saving of all the special fixtures and jigs to evolve these parts, and it's completely transformed automation. Or there's still, it's taking automation to a completely different level. Is what I'm trying to get at. It's simplifying it. Is that the case?
Yeah, absolutely. I mean, and it's all about swift changeover as well. You haven't got a day's setup to rejig a set of bowl feeders to get to run a different type of part. So you're able to run lower volume batches more efficiently without any intervention.
And that's another question, really, that I had on my list. Really, there's such a massive misconception that automation is only for high volume work, and if you're doing low volume or medium volume, it's not for me. It's not going to help my business. Ian, is that true?
To an extent, there is some truth in there, but that's becoming less and less the case as we go forward. So I would say historically the sweet spot for investing in a vision system would be continuous production of the same type of products, and then like any automation, it warrants investing good money in that automation to get a really efficient process to bash out those parts. But like Bob was saying, what we do see is if your tooling change is software, so the vision system's changing over, we're recognizing some different parts and it's giving some different coordinates to the robots, then your changeover time drops right down, and that does allow you to run smaller batches because, okay, there's a bit of overhead in setting up the vision system to check each given part type or identify each given part type. But if that changeover is just a button click on the screen or reading a barcode to switch it over automatically, then that does facilitate those faster batch changes. And we're also seeing with the maturation of the products in our industry that as we're getting to the maybe slightly lower price points with some of the cameras and some of the inspection systems, then the overhead to investing in those for smaller batch runs or more lower volume processes is no longer a concern, or as much of a concern, because it can help and augment a human inspection. And the big benefit of the vision systems has always been that they are totally objective. There's no subjectivity with them, which we've seen examples of before where customers have had manual inspection and the inspectors swear blind that the parts are good, but the vision system says that they're not. And we've had it proved in the past that the operators and inspectors are very good at spotting an anomaly if they're presented with a bunch of good ones and a failure within that. But if all the parts are consistently looking the same, but they're all bad, they don't spot the difference. They just see them all looking the same and assume they're good. Whereas the vision system will be set up with given parameters, and if the parts don't conform, then the vision system will reject them. It doesn't matter, what they're surrounded by, what the preceding 1, 2, 5, 20 parts were. The vision system will make the same decision every time.
Yeah, I mean that's a great answer, and I mean I'm going to go on to Bob in a second, but I mean effectively, just to try and summarise what you're saying here, Ian, is like you mentioned previously and alluded to previously, you can kind of detect an error before you add even more value onto the part, especially with some of these really complicated components that are worth a lot of money. The last thing you want to do is add more value, do more machining to that part. you can automate high or low volumes in a more cost-effective manner. And ultimately, you can start automating lower volume work as well as high volume work and create unmanned running overnight. So you can double up your shift and keep them spindles turning. Bob, I know you wanted to say something. Can you let us know your thoughts on this?
Yeah, I was just going to say that looking at the justification for an inspection system on a product is kind of there's three ways of you might have a high value part that needs to be right, so you can just although it's low volume, it's high value, so that could justify inspection. You could have a low value part, but you're making millions and millions and millions of them, so you don't want duff ones go, because if you make a duff one, let a duff one go through, you can get recall problems from your customers. When you've got to do manual inspection of thousands of parts, maybe in another country. So I think there's no justification for making sure the part's right. And then in some cases, it might be a cheap part. Where it goes in the final assembly, it means a failure could cause a really expensive problem. So you imagine a washer in a gearbox. That washer fails, it's a gearbox stripped down. Might be only a tuppence halfpenny part, but it's going to cost a very expensive recall and rebuild. So there are many ways of justifying the inspection costings beyond just high volume and low volume.
That's a really good point. Well, very good points. And so in your opinions, what are the barriers to entry to machine vision? What barriers to entry do you come across out in the field?
So some of that we see. So some of it is expectation driven. That people see maybe what your camera can do, or what the sort of current state of the art of Google self-driving cars or something like that can be, and they say, well, I can see this defect, therefore I can inspect it. It must be dead easy. But actually, to make that a reliable and repeatable process, which is what you want for an industrial inspection, may present some other challenges. The other thing that we often see is part presentation. That if you're looking to make a very accurate inspection of a part, you need to present it to the camera as reliably as you want to inspect it, or even more accurately, you need to present it to the camera than you need to inspect it. So the transport mechanisms, the holding, the handling of the part to present it to the camera can also be a key aspect. And I guess this may be a point to sort of add that this is where we tend to like to work with machine builders and machine manufacturing companies who are maybe experts in the part handling. They're experts in the moving and holding of the parts, and we can work with them and bring the vision expertise to that. And it tends to be a very collaborative process how we work with our customers to ensure that collectively we get the best out of the vision system as part of the automated process.
Yeah, I can see the benefits in that collaboration. How important is the lighting? Does the lighting play a part in the vision?
The lighting for a camera system is our source of information. So imagine that a camera can't see anything if there's no light on. So controlling the lighting is probably the single most important aspect of any vision system, and often a bit that's overlooked in preference to some of the camera manufacturers selling how whizzy or shiny their new camera is, what fantastic software tools they have. But if you haven't presented the data right, you haven't got that consistency of lighting in the first place, then your inspection is likely to always struggle with that, because you're not necessarily just looking for changes in the presentation or how the part looks and how the defect may look on that part, but you're also having to cope with the fact that the lighting keeps changing. The sun's come out, the sun's gone away. They switched the light on overhead. Somebody's shining an inspection lamp into the system, and suddenly you've got glare on a part. And this can become particularly important, certainly with machined parts, because often they are very reflective, very shiny parts. We had a system probably 10 years ago now that ran for 5 or 6 years absolutely perfectly, never missed a beat. We had a camera on the outfeed of a CNC checking for a fairly simple check, just checking for swarf having been wrapped round the end of the part and not being cleaned off in the process, because they went straight to the customer off the back of this machine. And that machine ran absolutely perfectly for 5 or 6 years, picking out the odd defect that they had. And then they rang us up I think it was a February day, and they said, we're getting high levels of reject. There's absolutely nothing wrong with the parts. What's happening? And we were able to assess the fact that the machine was just happened to be where a skylight was in the factory, and being the factory in Wales, they didn't often see sunshine in February, but this February they had a clear sunny sky, and the light was shining in at such a low angle straight through the skylight and almost perfectly illuminating the part, and that extra reflection from the sunlight just caused the part to look completely different, and we were rejecting them.
Wow.
So the remedy was fairly simple. It was we had the vision, the lighting was already in the system, but it just wasn't shielded from strong ambient light. So the answer was fairly simple. The customer put a little metal cover over the camera area, and the problem never occurred again, because now the lighting was constrained to just the light that we had alongside the camera in the system, and it was fine. So yeah, we're also aware that although a complete enclosed black box is the ideal for the camera system, because that's blocking out everything, any other light interference, often when customers are having these vision inspections, it's part of a process that they either need to see for operational reasons or even for commercial reasons, that when the MD comes around with some new customers and they say, look, here's the automation we've invested in, isn't it fantastic? Look through this window, all the super technical things it's doing. They like to be able to do that and not have it, well, inside this black box, something magical is happening, but you can't see it because the vision system needs it. So there are ways we can protect systems and still give visibility in, so that we can get around all those things.
Yeah, so it's again raised some fantastic. You enlightened me, Ian. Bob, now, like for our listeners again, that are listening to this podcast, does your technology check the parts as kind of a comparison, or does it check the parts dimensionally too? Does it give you kind of a report? What information does it give to a potential client?
Really, how you want it. I mean, a lot of systems are systems comparators. We train it on a good part, put some tolerances on it, and those measurements will be tested against that known good part forever and a day. Or we can make absolute measurements for parts that maybe not the same size every time. They're made to different sizes. We can measure what they are and report the sizes back. So right. It's all of the above, really.
Yeah, so it's flexible. Now, guys, what is the most surprising thing that you've been asked to do as machine vision experts? Bob, start with you.
Count salmon in a river.
Seriously?
Seriously. I'm trying to recognise it's a duck's backside you're looking at, not a salmon.
And Ian?
Yeah, I mean, it's the more off the wall products are always the ones that jump out, because they're not sort of boring and trivial. We've got one at the moment where we're counting insects, which is just completely different to almost all the other systems that we've put out there. but it's a technology that we're able to leverage now that we weren't before. So it's a we're using techniques now which are based on a type of artificial intelligence, a subset of that, to allow us to work with images and classify objects that were hard to put a rule together to work with before. So traditional vision systems, you tend to be saying, I'm looking for a measurement, or I'm looking for a presence or absence of a feature by counting how many pixels, or checking for a color, or checking for a pattern or a shape. But we've now got access to these deep learning technologies where you can teach products based on a number of good samples and then look for anomalies and defects. So that can be particularly good for objects where they are not a standard shape or size, but you can teach lots of them, like insects or fish or food products, but also any products where you've maybe got a finish to them. So this might be variation in a powder coating, or variation in a material finish, or even a material grain. If you've got cutting marks that vary, but you're looking for defects such as material changes, corrosion, things like that, or even welding patterns and shapes, we can now inspect those by teaching it a bunch of good products and saying, this is what a good one looks like. Tell me when it doesn't look good anymore. And that's now quite a game-changing technology, allowing us to look for all sorts of different products that we couldn't have done 5 or 10 years ago.
So that really nicely leads me on to my final question, really, guys. Where do you see the future of machine vision, and do you see yourselves working more and more with artificial intelligence, and how far can it go, Bob?
I think, yeah, definitely. We will see more and more of these artificial AI type systems coming through. I think more and more applications will be opened up as a result of it. And systems will get easier to use and deploy, and there'll be a much greater take off within the automation, factory automation in general. And I think there's a necessity for that to keep costs down. Stopping rejects going out the door is going to be key.
Yeah, I think it's. I think that, in my opinion, I think that production and manufacturing, the inspection side of it should be looked at on as one complete process, rather than the machining, the production, and the inspection as two singular kind of processes. And I think with your technology and products, it does seem to bring the two together quite nicely. And I think we'll be seeing a lot more of them as standard in machine tools. And Ian, just to kind of wrap up this MTD podcast, where do you see the future of machine vision?
Well, I think we're, as Bob said, really, we're going to see this now. I think we'll see two things. One is we'll see more of it embedded as part of machines as they come through to get this no fault forward process, that rather than having maybe a sensor or some sort of gauge or even just a work instruction to how you set something up, we'll start to see little embedded camera systems doing some of those checks automatically. Maybe quite specific checks, but having those built into machines, and people will start finding those, without necessarily realizing that's what they're doing. It's just saying it's good or it's bad, it's ready to go, it's not ready to go, right through to the other end, where we're seeing more and more systems where we're able to leverage some of the technologies that are filtering down from maybe more consumer areas. So some of the deep learning techniques, some of that is filtering down from what software industry leaders such as sort of Google and Amazon are working on and those techniques are filtering down and becoming industrialized and turning into products that we're able to deploy within a reasonably quick time frame at a reasonable cost, but also have that reliability and longevity that industry requires.
Bob?
I think also we'll see the inspection kit being used within the process as well. Checking tooltips, checking the manufacturing process as it occurs. So rather than looking at the product, looking at the tools you're using to make the product.
Yeah, it's for me. I think it's absolutely unbelievable. I think that this new technology is fascinating, and I can't believe that the speed in which it's kind of evolving. Effectively, in my opinion, you're giving robots eyes, and the AI is giving robots a brain, and it is really, really fascinating, but it's also scary at the same time to a certain degree. Bob, Ian, it's been an absolute pleasure to have had you guys on the MTD podcast this week. To all our listeners, if you've got any questions at all about vision machines and machine vision automation, please contact Bob or Ian, and they'd be happy to assist you with any potential solutions. Thanks for listening to this week's MTD podcast, and until next week, stay safe and keep tuned in.
Thanks for listening to the MTD podcast. If you found value in this episode, please subscribe and leave a rating and review. Find more episodes on MTDCNC.com.